Welcome to Back to the Basics. I'm your host, Walt Boyes, Editor-in-Chief of Control and ControlGlobal.com, reporting for the Process Automation Media Network. This episode is about PC-based control. Wherever we look, we find computers. In process automation, we find them in displays, in networking appliances, in machine controllers, in HMIs, and in industrial controllers and PACs, programmable automation controllers. We find them in low-power portable devices and even in field transmitters. Most of them don't look like traditional desktops or laptops. Dick Morley, who's credited with inventing the PLC, is reported to have said, "It was always a computer. We called it a PLC to keep from scaring the operators." When PCs were being developed in the early 1980s, the processor chip itself was very expensive and required special handling like special power supplies and cooling. It just wasn't economically feasible to embed high-level processors in hardware and appliance-type devices or even in field sensors and controls. Typically, smaller, lower capability processors were used or hardwired digital logic was used. By the early 1990s, though, the cost to produce an Intel or AMD x86 level processor had reduced to the point where engineers and product designers found they could use standard PC level processors instead of the venerable Z80 or Z88 or custom designed logical devices. This newfound power immediately allowed programming in higher order programming languages. This quickly opened up the world of device design to anyone who could program for the PC. The higher power processors also provided a vastly increased capability to perform operations and gave device new advanced features. The standardization on USB made possible simple industrial-grade peripherals and auxiliary equipment without custom operating systems and legacy devices. And the development of the tablet PC and the low-power portable PCs made industrial-grade, low-power versions of these devices available. All of them were compatible with standard PC-based architecture, and all of them ran some version of Windows OS. Throughout the process enterprise, we see a plethora of general-purpose computing devices performing a variety of tasks on the plant floor and at the enterprise level. You can't just take a motherboard and a display off the shelf and install it in an industrial environment. It's critical that you select devices that are suitable for the service you expect to put them into. Moving parts, even ones like fans, coolers, and disk drives, just do not survive in the industrial environment. The power supply must not require fan cooling. The device should have solid-state memory and solid-state data storage as well. The price of 1, 2, 4, and 8 gigabyte USB and CF memory sticks has come down to significantly less than $100. PC-based controls should be available in a variety of configurations with the same programming and performance characteristics, whether they're embedded in an HMI or in a panel-mounted device, a rack or DIN rail-mounted device, with as few connecting cables as possible to prevent vibration-based failure modes. The circuit board must be designed for industrial service, not a general-purpose PC motherboard. Components should be soldered wherever possible rather than connectorized, again, to prevent failure. And the PC-based controller needs to operate over a wide temperature and humidity range, much wider than commercial products do. Today, you can find PC-based controls in nearly every device. This has been Back to the Basics, PC-based controls. I'm Walt Boyes for the Process Automation Media Network reporting. Good day.